Welcome to example 11. We have a combination of circuit of resistors that involve resistors in parallel and in series, and we're asked to find in part A the equivalent resistance. We simplify the network of resistors in a series of steps. At first, we have to look at the innermost resistors. So what we want to do here is take a look at these two resistors, R3 and R4, and find the equivalent resistance of these two together. So let's start off with that. 1 over R3, 4 equals 1 over R3 plus 1 over R4. That's 1 over 6 ohms plus 1 over 3 ohms. And we can see we have a common denominator of 6. So this would give you over 6 ohms. We would have 3 on the top, and this would simplify to 1 over 2 ohms, and therefore resistance 3, 4 would be the reciprocal of that, which is 2 ohms. So now you can think of this combination. Now you can replace this circuit now with just basically one resistor for R3 and 4. So let me go ahead and do that. So now I've redrawn my circuit and erased a few things and put in resistor 3, 4 of 2 ohms to replace the 4 and 2 ohm resistors that were in parallel before. Actually, the 6 and 3 ohm resistors that were in parallel before. So what we now want to do is now add that 4 ohm resistor and that 2 ohm resistor that are now in series and find the combination of those two resistors. So the equivalent resistance of this from, we'll say 2, 3, 4 would be equal to the resistance 2 plus resistance 3, 4. So that would be 4 ohms plus 2 ohms, which gives you a total resistance of 6 ohms for that top connection here. So what now I'll do is I will replace these two resistors here now with one single resistance of R234. And so now for my last step, what I'll do is I'll add this 6 ohm resistor here with the 9 ohm resistor that are in parallel with one another. So the 1 over the equivalent resistance would be equal to 1 over 6 ohms plus 1 over 9 ohms. And then we will then take the inverse of that to find the equivalent resistance. And we will get an equivalent resistance of 3.6 ohms. And that's part A. So now we can think of this now as one complete resistance, one circuit with just one resistance of 3.6 ohms. So let me redraw that once more with just one single equivalent resistance. And so that if I wanted to, for example, find the total current through the circuit, if the EMF was 0.6 volts, I could just use this 3.6 ohms, and we could use something like EMF equals IR, and knowing 0.6 volts and the total resistance is 3.6 ohms, then I would find the total current I. Now that is not going to give you any of the individual currents because those are now over branches. So let's go back to our original picture, because in part B we're asked to find the current through resistor 2. So in part B, to find the current through resistor 2, that would be current I2 as labeled in the diagram. And to find that current I2, we need to be using the voltage drop over R2. Now there are a couple ways to do that. I think what would be good to do is to go back to our earlier diagram that involved the 4 ohm resistor, which is here, and then the equivalent resistance of these two together, which was 2 ohms, and look at that branch. So let me go back and revisit that and redraw that diagram with just these two written in together here. So now you can see I had that 2 ohm, but really I actually want the voltage drop across this whole thing because we would like to find the current through this particular section of the branch here. So let's actually add these back and we'll find out. Let's redraw this with one single 6 ohm resistor. So therefore the voltage drop that would occur from this point right here to this point right here would be in parallel to the battery. So the voltage drop across this equivalent resistance of 6 ohms is 0.8 volts. So if you use Ohm's law, the current through resistor 2, which is the current through this branch here, is equal to the voltage over that branch, which is the EMF, divided by this equivalent resistance between 2, 3, and 4. So our resistance 2, 3, 4. So that's 0.8 volts divided by resistance of 6 ohms. Oh, I just realized that should be actually a 0.6 volts. So if you divide 0.6 volts by 6 ohms, you'll get 0.10 amps. So there is a current of 0.1 amp going up through here.